Hi, and welcome to this SharePoint-based conference session about using Microsoft Graph APIs. My name is Vincent Barrett. I work at Negotium Technologies as a product team tech lead. We're based in Montreal, Canada. I've been a SharePoint MVP for 1 year and a half now, and you can reach me out via Twitter, my blog, or my email address. During this session, I won't be able to answer your questions live, so Sébastien Lever is going to answer your questions on the chat during the session. So he's also working at Negotium as a technical advisor. He's Office 365 MVP, and you can reach him via Twitter, his blog, and so on. Who's that session for? End users who want to understand the value of the Office and the Microsoft Graph, and developers who want to understand the concepts and know how to use the APIs. Before we begin, I would like to highlight some available content for you. Most of them are sessions from the Ignite, a deep dive into the Graph API, delve in Office Graph roadmap, building solutions with Office Graph, and the MVP panel showcasing the graph. And some content about the theory of a graph will come from the graph databases for SQL Server Professionals from Stéphane Fréchette. He's a Canadian SQL MVP. Today's agenda, what are we going to talk about? The first thing is what's a graph, what it is, what's the theory behind that and how it works. So we make sure that everybody understands and talks about the same thing when we talk together. Then we'll talk about the Microsoft Graph, what it's provided, what it is going to be, what are the APIs and things like that. And we'll also demonstrate a couple of things, and then we will just conclude our session. What I won't be showing today is Office Delve. Delve is simply a client for the Office Graph you have in Office 365. It's simply a client, and I won't show that today. Sorry if you wanted to see that, but maybe other sessions will show that. I won't show Power BI because you can use the Graph APIs with Power BI and do stuff with that. I won't show that today. Sorry again if you wanted to see that. Maybe other sessions will cover it. And we won't see too much code, only some HTTP requests and stuff like that. I won't spend my time in Visual Studio, so we will see the APIs, but that won't be a full coding session. What is the graph? If you ask yourselves these questions, what's a graph for you? If I say the graph word, and maybe that part will talk more to the English speakers listening to us. So what's a graph? Is that a graph? No, that's not a graph. That's a bar chart. Is that a graph? No, that's not a graph neither. That's a pie chart. The reason I'm saying that is because most of the people imagine that when we are talking about a graph, we are talking about some presentation of data, something you can draw, and that's very visual, and that's totally different. That's not. These are not actually graphs. These are charts representing data, but don't make any confusion between that and the actual graph we are going to talk about. So first, let's begin with Wikipedia. What's a graph? A graph is a representation of a set of objects where some pairs of objects are connected by links. Thanks Wikipedia, that's a very generic definition. Again, the graph theory is the study of graphs. So if we are looking at the explanation and the application for computer sciences, the graph is simply a data type, data model designed to implement the graph theory from mathematics. So that's simply a concept we took from mathematics and used in computer sciences to do things with it. So just to be a little bit clearer than Wikipedia on the definition, that's a graph. Here you can see objects 1, 2, 3, 4, 5, 6 and links linking them together. So you might have noticed that nowadays everybody is talking about Graph. Facebook, Google, Microsoft, and other vendors are talking more and more about Graph. And why is that all of a sudden a very famous, very trending? That's because the industry came to a conclusion that RDBMS are really bad at doing things that they are not meant to do. Let's imagine, for example, if you have a database where you have a users table and another table which is friend of. So one user is a friend of another user, and that's how you express the idea of a relationship, a friendship between two users. If I ask you the question, who are the friends of Tom? That's a very easy question to answer. You only have to do a join, and that's very easy. But if I ask you a question, give me the friends of the friends of the friends of the friends of Tom, that's way more complicated. And even if you are able to express the query in order to do things like that, it will be very costly for RDBMS to give you the result of that type of query. So that's why everybody came to the conclusion that we needed graphs, because during the years 2000s, everybody was storing everything in RDBMS, and then we had a lot of performance and expression issues with RDBMSs. So just to recap a little bit about different databases paradigms, you have first the most known paradigm for databases, the relational database management system, which were meant for forms data coming out from forms. Then you have the hierarchical database management system. That's meant for hierarchical stuff. Imagine, for example, the Active Directory. Imagine other things like that. The data is stored in a hierarchy. Something belongs to something else. Like the taxonomy term store from SharePoint. Another one which is more and more famous recently is the NoSQL family. The idea of that kind of database management system is that it's high performing, non-normalized, and in order to store stuff which is not linked together. Another one is the document database management system or indexing system, which is meant for search, index, and queries like that, a flat search system. Cubes, database cubes for analysis are a kind of a solution, a patch of RDBMSs. The conclusion was because our RDBMSs are not performing well enough when the data is normalized and structured, we are going to expose and transform our data from normalized to a star system or other systems like that. And in order to be able to run reports, complicated queries without impacting the production, without impacting the RDBMS. So that's kind of a fix because we needed more performances, but that doesn't work very well. And then finally, we came to the conclusion that we needed graph database management systems for connected objects. The idea of graph, and we'll talk more about that during this session, is that graph or for connecting things. They have this idea of objects and link, and that makes it very easy to navigate from one object to another one, to another one, to another one, to another one, and so on. So the theory being said, one of the most common implementation of the graph theory in computer sciences is the property graph. The idea is we have two kind of objects, the nodes, which are representing our entities and objects and so on, and links between them. Both either nodes or links can have a type, and when I say type, that's not a very strongly typed type, like the like you have in OOP or stuff like that, but that's more of a metadata saying that this node is this kind of thing, but that's not very strict. It doesn't matter for the properties or things like that. Both can have properties. So let's say we'll see an example later. And links can have a direction. So I can be a friend of Tom. Tom can be my friend, and we can be friends together. But links have a direction, so it can go when we walk the graph. It can be from one way to another way, or both ways. So here is an example of the property graph implementation. Let's say I have one first kind of object, which is a user or an employee. In that case, that's me. So the ID of the object will be Vincent. We have some properties. I'm set at the desk E43. Here is my phone number. Here is my extension. Another object is the company, which is Negotium. We have properties like the street address, the date of creation of the company, and then we have a link between these two objects. Sorry, which is works at. So the idea of the nodes is that they express entities, and generally the links express actions or things like that. So Vincent works at Negotium, so that makes sense when you read it. You don't have to express a complicated request to express that ID. And on that link we have probabilities. So Vincent works at Negotium since the 12 July 2012, and so on. We have another kind of object, which is the kind of I don't know, the role we have in the company. We have one first role, which is the technical advisor, and a technical advisor must do technical advising. The advantages of being a technical advisor is you have a better business card than the other guys in the company. You have another role, which is a developer. What they must do is development, of course, and the advantages of being a developer is that they have better keyboard than the other guys in the company. So as being Vincent and as being a developer and a technical advisor, I work as, and that's a different kind of relationship, a technical advisor since 2014, and I've been working as a developer since 2012. And so we can easily, with that kind of model, answers questions like give me all the technical advisors working at Negotium Technologies, or give me all the developers working at technologies since 2012, or things like that. And that's very easy to express even very complicated request with that simple model and that connected objects model. One of the questions you might be asking yourself is why are computers so good with graphs? That's because graphs can be very easily represented by matrices. The reason why computers are so good with playing with matrices is because when you want to add two matrices together, you just have to do whiles or loops or things like that, and computers are very, very good at doing very simple operations, but a lot of time. And so that's the reason why when you take a graph with a lot and lot of nodes and links and data in it, and you express it as a matrix, and then you take your request and you also express it with a matrix, and the only thing the computer has to do is do some basic matrices manipulations, which are in behind only loops and stuff like that, in order to have the result of the query based on the result set. When they play with matrices, it's very easy to compute for CPUs and computers in general, and that doesn't take a lot of memory to process, because that's only large sets of numbers, and that's it. And that's very lightweight, that's very easy for computers to do, and that's the reason why they are so good at playing with matrices, and therefore with graphs and stuff like that, which is way more complicated when you have complicated requests for RDBMSs or other database management systems. I picked some usages of our everyday's life of the graph theory in computer sciences. One of the first application is the internet. When your computer sends a request from your computer, for example, to the YouTube server because you're watching a video, all the data is streamed as small packets of data, and these packets find their way because of the routing tables, which are in behind expressed as graphs, and the routers find the path from point A to point B because that's graphs. They are working with graphs in behind. Another application is the data centers maintenance for a large cloud provider. And when they have something failing in data center, it's very hard when you have hundreds, let's say thousands of servers, thousands of switches, routers, and stuff like that. But if you represent your whole data center as a graph, and then you can easily isolate and identify which is the failing point from point A to point B, and quickly replace and fix the issue. Another great application of the graph is the GPS. The maps and the ways and the path and the roads and all these things are represented in behind as graphs, and that's very easy for even a very small device with low CPU and low memory and things like that to find your way between huge data and huge maps, because everything is represented as a graph. Another recent application are all the social networks. So let's think about the LinkedIn recommendations and stuff like that. The way they do that is because they use graphs behind. Another application is the e-commerce. When you are on a website trying to sell you stuff, and when you add something to your cart, and the website is recommending you things you might like or things you might order with your cart, with your what you ordered just before, is either based on statistics or because we have a graph database behind that. And also the way you navigate through the catalog is most of the time for performances reasons, because based on the graph behind that. Banks also have been using graphs for a long time. They use it as fraud detection patterns and stuff like that. So if someone is using your credit card in Jamaica, for example, and you are based in Canada most of the time, and that's a big amount, and that's on a merchant they're not trusting very well, that might trigger an alert or stuff like that, or block the transaction. And the way they do that is because they have huge graph databases to be able to detect these patterns and trigger alerts in a timely manner. During this demonstration, I will be using Neo4j, which is an open source graph database management system. What I've done is I've used another API, a natural language processing API, in order to read my blog posts from my personal blog, and for each post I extract the language, the entities, the concept, and a few other informations. What I'm gonna do is I'm going to execute the first request, which will bring me back everything I have in my database. Let's make this bigger. So you will see dots and links between the dots. Red dot is a language like French, English, Spanish, and things like that. Purple dots are entities. Entities can be persons, places, brands, IDs with a very unique name. the blue, the cyan dots will be concepts, so IDs without a specific names, without a specific identity. Purple will be keywords, like keywords can be used for SEO or things like that. Yellow will be offers, and blue will be the documents, in our case the blog posts. Using a graph database engine, we can see quickly that items are related together by some IDs or some concepts with So using a graph database engine, we can see that some documents are related together. We can see, for example, that the document number 890 is related to the document number 894 by this entity, which is in our case Microsoft. So these two blog posts are talking about Microsoft, and we can see they are related together. In a similar case, we can see that the 884 is related to the 894 by this keyword. They all have together this single keyword. Or the 896 is related to the 884 by this other entity, like the city of Montreal. So these two blog posts are probably talking about an event happening in Montreal. So that doesn't bring a lot of information to have all these items linked together, displaying on the screen, and we can simply play with bubbles and that's it. What we can do is we can build more interesting requests. Let's try to bring all the documents talking about Chicago. We can see that we have multiple blog posts here in blue talking about the city Chicago. Why we do have that? Because on my blog I have multiple blog posts talking about the Ignite, and that's something interesting to see that some blog posts are related because they talk about the same entity. But again, that's something easy to do with an RDBMS. Let's say we want to have all the documents talking about Chicago, and where we have the idea of Chicago is something relevant that has a lot of importance during the in the blog post. Based on the three documents we had previously, we only have one talking about Chicago, which is an important concepts in the blog post. But again, that's something easy for an RDBMS. Let's say we want all the documents talking about the same entity together, and that entity being Microsoft and Chicago. So here we have three blog posts, and all three of them talk about Chicago and Microsoft, both concepts together. So that's something way more complicated to express with an RDBMS. So what I expressed is I want all the documents related to two entities, the first one being Chicago, the other one being Microsoft. But let's try something even more complicated. Let's try to get all the documents talking about Microsoft, or talking about something which is related to something talking about Microsoft or Chicago. So that one may take a little while to execute. So we have more documents, because these two, the 894 and the 888, are talking about Chicago here, and these two are talking about Microsoft, the 881 and the 896. But because this one, which is not talking about Chicago, is related to another one talking about Chicago, because they are also talking together about SQL Server, the graph database engine will bring me back. the, this introduces an idea of distance between all the nodes and links you can have. So as you can see, you can easily walk the graph and say, I don't want only nodes directly related, but related from a certain distance together. So that's the essence of a graph. It's very easy to have things linked together, even if they are not directly linked together. So it's very easy to go from one node to another one to another node and bring interesting data from the graph. Now that we've introduced what's the graph, the theory behind that, and we are all using the same language and the same terms to talk about the same things, we'll talk about the Microsoft Graph, what it is and what it provides. So why Microsoft is investing a lot in the graph and things like that? Because the first reason is other industry majors are doing it right now. Facebook has been working on graph for a decade right now, a social graph for a consumer graph, and they use all this data to for marketing purposes or for applications or things like that. LinkedIn also has been using graph for a long time in order to connect people, to recommend people, to do things like that. Amazon has been using a lot of graphs in their systems. One of the most famous application is IMDb, the international movie database. The way they can pull up movies and actors and roles and credits and all the stuff you can find in IMDb is because they have a graph working behind that. Google is also working on a project called Google Knowledge in order to do a clever knowledge-based management slash recommendation slash AI stuff like that. So all the other majors have been working on graphs recently. So that's one of the first reason. Why Microsoft has been working on a Microsoft Graph and graph applications for Microsoft products. One of the first reason is because right now you have SharePoint on one side, Exchange on one other side, Link or Skype for Business, and so on with Yammer, with OneDrive and things like that. And all the data is separated, and it's very complicated to relate things coming out from Exchange, from SharePoint Online and Yammer together and link them together and have some clever knowledge about your data in the company. Even if you are using, let's say, Office 365 and everything is operated by Microsoft and maintained by Microsoft, it's very complicated to have data across all these separated systems. So they needed something on top of that to expose all the data and to be able to relate the data together and to link the data together and to use it. Also, another reason why they are providing a graph API and things like that is because accessing different workloads, so SharePoint, Exchange, Link, Skype for Business, and so on, is very hard because you have to manage the authentication, you have different APIs. So as a developer, I have multiple endpoints, and it's complicated to access all these different systems, and all the URLs might be different, and that kind of problem. So that's also one of the other reasons. Another conclusion we've come to in the last decade is search simply doesn't work. Ask yourselves, how many times have you heard in your company or at your customers, the SharePoint is great, I can work and can collaborate, I can put documents and stuff and tons of data, but every time I'm looking for something, I can't find it because the search experience is very poor. One of the reasons is because the search index is flat, it doesn't index items related together by default, and it's very hard to do clever guesses on flat data. So they needed something else which was more proactive, which was more clever than the actual search experience, and that's one of the reasons why they are investing on a Microsoft Graph. And the general idea behind that is we want to improve data access, search experience, and workloads access. But the general idea is that it will allow us to do new things like point out new ideas in the company, things we would not have guessed or thought about before. So that's the idea of a graph. It will help us to discover new things in the company, new ideas and relationships and things like that. So when Microsoft is talking about the Microsoft Graph, they are actually talking about multiple things. We are first talking about the unified APIs. So I don't know if most of you have been developing for Office 365 lately, but 6 months ago, or maybe 8 months ago, Microsoft came with a new API and a new way to access workloads in Office 365. Instead of doing SharePoint applications, of using Exchange web services, of having quite nothing for a link and stuff like that, they came with APIs you can access with a single authentication mechanism across all the APIs, and we call that unified APIs with access for the files, with Azure Active Directory, groups, SharePoint, Exchange, and stuff like that. So all these APIs are now together under the graph.microsoft.com. One of the main reasons is because before, when you wanted to access these different APIs, you had to get first an authorization token and then an access token to each of the API. And now, because of the Graph unified APIs, you don't need to have multiple tokens and authentication mechanisms. Only one set of authentication and access token will allow you to access all the APIs across all the workloads on Office 365. It's also bringing another concept, which is the Office Graph, which are clever things, and we'll talk more about it later. From the graph, also it brings the search index. It brings a lot of other things. Azure Active Directory graph also is included in that graph. So when we are talking about Microsoft Graph, we are talking about multiple things actually. So if we want to have something, if we want to express it in a easier way to understand, you have first these unified APIs I was talking about here on the blue on the left, so the users, group, files, mail, calendar, and so on. And then you have what we call the Office Graph, which are based on two things. It's based on what we call insights. So that's something, because objects are all together and connected and things like that. The graph will be able to guess things about the users or the data or stuff like that, and to give you access to these guess using endpoints. You also have access to the graph query engine, which is based on the search index of SharePoint. So you have a lot of things in the Microsoft Graph, and sometimes it's confusing. And also they are putting a lot of energy in putting everything together at one place, because it's something they want to be very easy for developers to use and to work with. So as I said, we will have in the unified APIs and the graph data coming out from SharePoint, from Skype for Business, from OneDrive for Business, Exchange, Yammer, Azure Active Directory, the video portal, search, the client applications, the Office client applications, and a lot of other things are coming to the graph. Based on the Microsoft graph, this is the way they define the structure of their graph. First, we have nodes. Nodes can be anything. It's basically items or entities like documents, emails, conversations, and things like that. Then we have a special kind of node, which are actors. Actors are basically users. And linking all these items together, we have what we call edges, or sometimes signals too. And if you want to know more about the data structure, you have in the slide deck links to the documentation. So some example of edges we can find in the Microsoft Graph API is modified. So this actor has modified this object, this node, sorry. This actor has viewed and so on. So that's the basic edges. And then based on the graph and the nodes we have inside of it and all the data we have inside of it, the graph engine is able to do some clever guesses with the data. For example, we have one insight which is trending around. The idea of trending around is I, Vincent, as a developer at Negotium, work on documentation, I talk to people, I send emails, I talk to people on Yammer and stuff like that. So that will be all the content trending around me, but that's not only it. As I, Vincent, I talk very often with my boss, with other guys in my team and stuff like that. And they also work on other documents, other emails, other conversations. So the trending around insight will bring me other documents I haven't necessarily opened or worked on, based on the people I'm working with, based on the kind of documents I'm editing and working on, based on my conversations. It will bring me new things I haven't played with necessarily, in order to make me discover new content in the company that might interest me in my context. Another insight is working with one of the issues with the user profile service from SharePoint 2010, 2013, and so on is people never actually kept updated the their profile and the people they are working with. So based on the documents I'm editing and the emails I'm sending and the people that are either modifying my documents or exchanging with me in conversations and stuff like that, the graph will guess who I'm working with in the company and will be able to provide that information for developers. Also, we will have other edges like the colleagues, the manager of an employee, and things like that. Some properties we can find on edges are the actor ID, so which actor is concerned by this edge, the object ID, so which object is concerned by this edge, the action type, so is it viewed, is it modified by, is it other things like that, and the time when the edge happened or a signal happened, and the weight of an edge, because edges can be more or less important. For example, the fact that I'm editing a document will be way more important than the fact I'm viewing a document, because I'm not implicated in the same way with that document in one case or another case. On the nodes, we can have multiple properties, and most of them are technical properties in order to make the graph work properly and so on, and defined by the graph model. But you can also extend these properties, because objects coming out from SharePoint will have all the properties coming from this search index schema. So if you add on documents some metadata, like new columns or stuff like that, and that is being indexed by the search engine, and you will find these values and these properties on each document in the Office graph later on. So how can you read the graph? You actually have, it's kind of messy these days because they are moving all the APIs and bringing everything to graph.microsoft.com, but not everything is there yet. And it also depends on the version of your tenant and whether or not you are in first release. And because this is something very new, Microsoft is investing a lot. They are right now developing this feature and these APIs and these things, and every couple of weeks they are delivering new endpoints, new way to interact with the graph. So the main endpoint for the Microsoft Graph will be and will remain graph.microsoft.com. Currently, it's in beta on first release tenants in a preview feature. Another endpoint to be able to express graph queries on a very low level is the search endpoint API for the SharePoint search index. So as you can see on the screen, you have first the tenant URL /_API/search/query. So that's the basic way you can send search queries to the search engine of SharePoint. Then you have the query text, so you can add some text to the query in order to filter out the values or things like that. And then you can add two things. In the properties options, you can add graph query colon and then your graph query. And after that, you can also select different properties from the graph specifying select properties. A few other endpoints, the trending around. So I already explained what it is. And the idea of that is that you get content trending around you and the things you're working on and stuff like that. Another endpoint is the users endpoint. You can access to the users and have information about them and the people working with them and stuff like that. Also in the Graph API. It's if it's not right now available in your tenant under the graph.microsoft.com endpoint, it will be there soon, and you can still use the outlook.office65.com endpoint to use them and to play with them. For this over demonstration for this session, I wanted to show you some of the APIs and some of the endpoints you already have available if you are in the first release program. They are really limited right now, but you still have some capabilities. What I will show is what are the endpoints available, but what I won't show is how you authenticate, get the authorization, declare the applications and things like that. That's something which has been very well covered either by Ignite sessions or by other blog posts or Pluralsight modules. For example, I'm thinking about the module from Andrew Connell, which is very well done to cover the authentication and application declaration part. So I'm going to assume that you already know how to build an application for Office 365, get the tokens, and get access to the API's endpoints. The first request I've executed is to get graph.microsoft.com/beta/me/files, and that will bring me all the files I have access to, starting with OneDrive for Business, but also some of them in SharePoint and things like that. But what I get when I execute that is an OData answer with metadata, with informations like what kind of type of data it is. Is it a folder or is it a file? What is it created by an application or by a user? In that case, I created that folder myself, so it's referencing to myself. It also gives the ID, and also it gives some edges like last modified by. it was last modified by a user. The ID of the user is the same because I'm the only person to have modified that folders, and so on. You have the name of the folder, you have the size of it, the that time created, that time last modified. But as you can see, you have a lot of metadata and some edges already available from these endpoints. The other request I have executed is graph.microsoft.com/betas/mytenantid /users and then the email address of a user. And what I get when I execute that is another JSON answer with again the object type user, the object ID, which is myself, so it's the same ID. And then you also have informations about the licenses and the plans I have access to, and what kind of SKUs I have access to, like Power BI, SharePoint, Exchange, and so on. And then you have other informations about myself. For example, I work in Montreal, the country is Canada, my display name, other stuff like that. Another request I have executed is the graph.microsoft.com/betas/tenant/users/users/files, which will bring us the specific file from a specific user. But again, the security trimming will apply. So if the app or the user making this request doesn't have access to all the files, he won't see everything. I've done the request on myself, so I will have the same result, obviously. But if another user doesn't have access to that data, he won't see it in the reply. Another endpoint we currently have, but in my tenant isn't available on the graph.microsoft.com. It's only available with the outlook.office65.com/API/beta/me/working with, but again it will depend on the tenant and when do you try it, because we are pushing everything to graph.microsoft.com. Is this one. So the answer we get from this endpoint is information about people working with, and again that's partially based on information from the user profile service and Azure Active Directory as my boss or things like that. But that's also based on informations that the Office Graph figured out using documents I've worked on. So we can see that we have an answer with people type. I'm working in my team with Jordan Baumal. We have his name, his email address. We also have Jean-François and their IDs and so on. And based on that, you can use that to then query their information later on. Another endpoint I wanted to show you is the trending around. So based on my coworkers and the files they are modifying and working with, and the files I'm working with, the Insight will try to guess files which might interest me and that I haven't seen yet. So again, same kind of reply, JSON. Again, we can see that we have multiple files coming out from this request, mostly documents that might interest me from the organization. You have these public endpoints which are under graph.microsoft.com and or outlook.office65.com, but you also have some private endpoints. For example, all the signals right now are stored using _API /signal store /signals. So that's not a public endpoint. So that's not something you should use right now. That's something that will come to the graph.microsoft.com. But again, if you want to play with that, and try to post some signals and add some signals. You can use that if you want right now, but again, the authentication is different from the public APIs and so on. The next question that might come to your mind is, how can I extend the graph? Because most of the ISVs would like to put their data into the graph, or add some edges, or add some metadata to the graph, or stuff like that. Currently, there is no API available for third-party vendors or ISVs to put their data into the graph. Two things you can do though is use the SharePoint metadata. So, for example, if you want to have to add specific metadata on documents or things like that, you can still create a side column, add it to the document library, add some data inside of it, wait for the SharePoint search service to index that, and you will find it later on the properties of your document nodes. You can also use the Office 365 Unified API if you want to add new objects. So if programmatically you want to add new documents, new conversations, new things like that to the graph, you can use the Unified API, so that will help you to add new nodes to the graph. But currently, that's the only things you can do with the current state of the APIs. So if we have a look to the APIs, right now what we have is we have the graph.microsoft.com endpoint, which relies on Azure ID, the Office Graph, the unified APIs from Office 365, also the search engine from SharePoint. So you already have that, but what you don't have is the APIs to extend the graph model, adding new metadata, adding new objects, adding new edges or signals. But that will be coming out pretty soon. What you also have available is, of course, HTTP endpoints like we saw, but also you have access to an SDK, which is in pre-release right now. I will put the links at the end of the sessions. Let's talk about one real-life use case, and that's something you will find in the Ignite session about the MVP showcase using the graph APIs. So Mavention made a meeting app for Outlook. So the what it provides is based on meetings and what you're going to do, and the graph API, where they will recommend you documents and other things coming out from the graph. If we have a look to some screenshots, one first thing, so here we have an Outlook Online, the Outlook Online experience. What they made is an Outlook add-in, the mail add-in to be exact, and on the bottom of the page, in the pink or section, what you can see is based on the content of this meeting and the people who were invited to the meeting, and based on the graph API, they've been able to retrieve documents related to documents to help the attendees to prepare for the meeting. They also have been able to pull out useful data about the attendees. They also have information about the customers' opportunities. They also are able to bring data from the CRM, like issues, like news from the client with the Yammer Connect, the Yammer module from for CRM and opportunities and stuff like that. So that's very useful. That's one real life example you have available for your meetings, and in order to be ready for your meetings, all at one place, the related content, and you don't have to put it yourself. It's being pulled out automatically by the graph for you. And you could imagine tons and tons of applications for your day-to-day business. You could add your line of business data to the graph. You could add some third party like SAP, like other vendors data to the graph to have everything connected together and have information of what is related to what and what makes sense, and how I'm going to use this data. Let's conclude this session. So a few tools first. I was talking to you about the Graph SDK for .NET. So you can install it using the Nugget Package Manager. The name of the package is Microsoft.graph. It's currently in pre-release, so you have to specify the dash pre in order to get it. That's not something production ready, but you can play with that. You also have the Graph Explorer 2.azurewebsites.net. That's a tool that you can use to play with the endpoints and see what's coming out and what kind of data and how is it working and what does it look like, and things like that. In the same way, you have the API sandbox, which allows you to play more with the unified APIs and the existing APIs from Office 365. But soon the graph samples and things like that will come to the API sandbox as soon as it is ready. Of course, you will need the Azure portal if you want to declare new apps and things like that, and an Office 365 tenant if you want to use it on actual data. So Microsoft has been investing a lot on the graph, as we've seen during this session. Right now we have two inside endpoints which are working with and trending around. We also have the unified APIs. We also have the search graph query language from SharePoint endpoint, and the Azure AD information coming out. That's really new. That's not a lot of data, and a lot of things will be coming to these endpoints soon. So stay tuned. And also, we don't have an extensibility yet, but it's coming. It's coming pretty soon, I guess. And it will allow you to make awesome apps and to think about the way you build apps in a new way. Instead of storing dead data at some place and very isolated data at some place, you will be able to have your data being related to completely different stuff and different data coming from different systems, and be able to guess things about it and to just do clever guesses about it, and then you will be able to use that linked data to improve the user experience and the way they use data, basically. To go further, you have other sessions talking about the graph and unified APIs during the SPBizConf conference. You have a lot of sessions talking about that at the Ignite. In the notes of the slide deck, I've put a lot of links to documentations and blog posts and stuff like that. Neo4j has been publishing a very good ebook to introduce you to the graph theory and to the application of the graph for computer sciences, and how you can build graph databases and the models and stuff like that. So definitely check this out. Play with Neo4j. It will help you to be familiar with the graph paradigm in computer sciences. And finally, you always have dev.office.com with a lot of samples, tools, explanations, and blog posts and stuff like that. Thanks very much for attending my session. I hope you enjoyed and learned plenty of stuff. If you have questions, Sebastien has been hopefully answering all your questions on the chat. If you have more questions, you can always send me a tweet. I will try to answer you as soon as possible. Have a great SharePoint Biz conference, and see you soon, guys. Bye bye.